Question 7. Determine the exact value of each of the following without using a calculator. So how do we tend to determine the exact value of a log? So here's our question A, which is saying we have log base 7 of 343. Now, before we solve these questions, I want us to understand the basic rules of a log. So let's say we have log base A of B k. So what it means here is that I can shift this to be in front of log. So this is the same as k log A of B. So now let's assume to say we've got the same things, and let's say we have log base A of A raised to the power x. I want to find the exact value of this. So now we are saying that the property of log allows us to shift this power to be in front. So I'll say this is x log A of A. So if you have got log of anything base of itself, that is definitely 1. Okay, so for example, this part here is going to give us 1. Then we're going to say 1 times x, in that case is going to be x. Now let's see. I have the first question, which is log base 7 of 343. Now this 343, how can we make it? We need to make that 343 to be 7 to the power a number, so that 7 and 7 should give us 1. Now if we do 7 to the power 3, okay, 7 to the power 2 is 49. Now 49 times 7 is going to give us 343. So meaning that this is going to be log base 7 of 7 to the power 3. Now the property of log allows us to shift the power to be in front. I'm going to have 3 log 7 of 7. This part here is going to give us 1. So we're going to have 3 times 1, which is going to be 3. So the exact value of this is basically 3. Now let's go to part B. Part B, we have log base 4 of 1024. Now how can we make it? If I do 4 to the power 4, if I do 4 to the power 2 is 16. 16 times 4 is going to give me 64. 64 times 4 is going to give me 1024. So in short, what I'm trying to say, 4 raised to the power 5. So I'm going to say log base 4 of 4 to the power 5. If you do 4 to the power 5, it's going to give us 1024. So the property of logs, I'm going to shift 5 here, log 4 base 4. So this part is going to give us 1. Without using a calculator, we can see that we're going to have our answer to be 5. Now there's another method which we can use apart from this one. Now I'm going to show you. So let's say we have, okay, let's use another method. If you want, you can equate this one equal to x. Okay, say this is equal to x. Now you can convert this into exponential, where we're going to say 4 raised to the power x is equal to 1024. So this is going to be 4 to the power x. This I can change it so that the base should be the same. This is going to be 4 to the power 5. So 4 and 4 will cancel, x will be equal to 5. So in this case, the exact value is 5, if you want it that way. Okay, now if you want, you can do it direct like the way I've done it. Now let's go to part C. Part C is saying we have log 3 over 8 base 3 over 8, then we'll go 27 over 512. If I want, I can equate it to x and then find the value of x. That is the exact value. But again, if I want, I can do it direct from here. I know that log 3 over 8, this 27 is the same as 3 to the power 3. Then again 12 is the same as 8 to the power 3. So I can write this and say is log base 3 over 8. Then I say 3 over 8 to the power 3. I can shift 3, which is the power, to be in front. It will be 3 log base 3 over 8 of 3 over 8. Meaning this part is going to give us 1. This part here. So it's going to be 3 times 1, which is 3. Okay. So the answer in that case, part C, is 3. Let's go to part D. Part D, we have log base 11 of 1 over 1.1. If you want, we can equate it equal to x and find the value of x. That is the exact value if you want. So I can say 11 raised to the power x is going to be equal to 1.1. But here there's 1 on top. Now I can say 11 over x is going to be equal to 121 is the same as 11 to the power 2. Now 1 over 11 to the power 2 is the same as I say 11 over x is going to be equal to 11 to the power negative 2. So this, the bases will cancel, x will be equal to negative 2. Meaning that the exact value of log base 11 of 1 over 121 is negative 2. But again, I can use the property of log to find the exact value without using a calculator. So there are two methods. You choose which one to use. You end up having the same answer. Now let's use the second one, like the first formula, 1 over 121. So this is going to be log base 11. 121 is the same as 11 to the power 2. Okay. So now this is 1 on top. It's the same as log base 11. Then I say 11 to the power negative 2. The moment I say negative, meaning this one has disappeared, like the way we did on question 1. Yes. So now I can shift negative 2 to be in front. 11 of 11 is going to give us 1, so the answer is going to be negative 2. Okay. Now let's go to part E. Part E we have log base 0.1 of 0.0001. But again, this is the same as if I say log 0.1, then I say 0.1. If I raise it to the power 4, it's going to be, as we can see, we have got 1, 2, 3, 4. So it has to be raised to the power 4. So 0.1 raised to the power 4 is going to be 0.0001. If you want, you can use that other method. That is just okay. So this is going to be, I can shift the power to be in front, 4 log 0.1 of 0.1. So this part is going to give us 4 times 1. The answer is 4. That is the exact value. If you want, you can use that other method where you equate it equal to 0. You find the same answer. Okay? You equate it equal to x, sorry. So what is f? F is log base 16. Now, this one, you can only use one method. Anyway, there are some other methods which you can use, but for me here, I'm going to show you one method on how to solve this one. It is impossible for us to, unless if it was log base 4 of 16. You can say 4 is the same as 4 to the power 2. But in this case, we have to equate this equal to x and solve for x. That is going to be the exact value. So I'm going to say it's going to be 16 raised to the power x is going to be equal to 4. I've changed now from log into exponential. Now, after changing from log into exponential, now we can solve this. Now, we know that 16, to make the bases to be the same, is going to be 4 raised to the power 2. Then this is the same as 4 raised to the power 1. So this is the same as 4 raised to the power 2x is equal to 4 raised to the power 1. The bases are the same, we can cancel them. 2x is equal to 1. Divided by 2, x will be equal to 1 over 2. So in that case, the exact value is 1 over 2. As simple as that. Now let's go to part the next one, which is part G. G is saying log, if you have not been given any base, meaning that is base 10, always. So in this case we don't have any base, meaning it's base 10, so it is 10,000. So that is definitely the base 10. Okay, if I want I can equate it equal to x, solve for x, or if I want I can just do it direct. So I'll say this is base 10, so it is log base 10. 10 to the power 3 is going to be 1000, but in that case it has to be to the power, it has to be to the power 10, to the power 4, because we have got 4 zeros, 1 2 3 4, so it has to be to the power 4. So it's going to be 4 log 10 of 10. So these, they will give us 1, so it will be 4 times 1, which is 4. So the answer in that case is going to be 4. But if you want, you can also use, you equate it equal to x and solve the value of x, where you are going to say this is equal to x. So it's going to be 10 raised to the power x is equal to a 10,000. I make the bases to be the same, so it's going to be like this. 10 raised to the power 4, the bases will cancel, x will be equal to 4, meaning the exact value is 4. Okay, so we have the last one. The last one is ln. Now they have given us a natural log, so we have ln 1 over the fifth root of e. Now ln is always in base e, but they will not show, it's the same as log. If they not give you any base, just know that it's in base 10. Okay, so same as natural log. Natural log is always in base e. So here what we have to mind is that here there is e, but they don't just show it. Okay, so in this case it's going to be ln 1 over the fifth root. If I have the square root of e, this is the same as e to the power half. If I've got the cube root of e, this is the same as e to the power 1 over 3. If I've got the fourth root of e, this is going to be e to the power 1 over 4. What of the fifth root? This is definitely e to the power 1 over 5. Now if I've got e to the power 1 over 5, what we have to know now is e to the power 1 over 5, I have got 1 on top. If I want to remove that one, I can say it is e raised to the power negative 1 over 5, meaning this one has disappeared, like the way we did in question 1. So now I have got ln e, remember it is in base e, negative 1 over 5. I'm going to say this, I can shift the power to be in front, negative 1 over 5 ln e. Remember this is base e, so base ln e of base e is 1. So I'm going to say the answer is negative 1 over 5. As simple as that. So that is it for question 5. For question 7, let's see how we can solve question 8. Now before we solve question 8, I want us to do question 9, then we come back to question. Let's first do this. This question is saying, write each of the following into single logarithm with a coefficient of 1. Now what is happening here is, if we know how to condense this, it's going to be easy for us to do question 8. So I feel like we need first to solve for question 9 for us to understand question 8. So now I'm going to give you a simple example. Let's say we have log, let's say it's in base 10 a plus log b. Now I can condense this to make a single logarithmic, to say if the bases are the same, at the same time there is plus here. So what you have to do, you just get log, you have to multiply what is inside. Here we're going to say a times b, so it's going to be a times b, meaning I've condensed this. What if there is minus? If there is minus, we divide. The one carrying negative is going to be on the denominator. I'm going to say log a, because log a is having positive, divided the one having negative is b, is going to be on the denominator. I've written now this into a single logarithmic. Okay, now in this case, let's see what we have. We have got part a, but this is question 9. Before we solve question 8, let's first go to question 9 here. So the first part is saying we have got 7. Okay, remember ln and log, they are the same. Okay, on that ln is it always has got base e. Log, if they have not given you the base, just know that it's in base 10. So I've got ln base we have got ln t, then 6 ln s plus 5 ln w. Remember last time I said, if I have got, let's say we have got ln x, let's say this is 2, this is the same as ln x to the power 2. This power can be shifted to be on top. At the same time, I can just shift this to be in front. Those are the properties of log. Okay, so in that case, we want to make this to be simple. I'm going to say this is the same as ln t to the power 7 minus ln s to the power 6 plus ln w to the power 5. Now that the I have the common thing here, I can do this. I'm going to say ln, the one having negative is going to be on the denominator, the one having positive they have to multiply. So in this case, this t and this, they're having positive, so they're going to multiply. So I'm going to say t to the power 7 times w to the power 5 divided by the one having negative, in this case is this, s to the power 6 is going to be on the denominator, meaning I've now expressed this into single logarithmic. Okay, from the expanded one, I've now condensed it. Okay, so that is the answer for part A. Now let's go to part B. Part B is saying we have half log z plus 1 minus 2 log x minus 4 log y minus 3 log z. Now here, remember, these ones, the ones which are in front, you have to shift them. They have to be on top there. They have to be now the power. So I'm going to say I'll shift here. I'm going to say I have got log z plus 1 raised to the power half minus log x to the power 2 minus log, okay, y to the power 4 minus log z to the power 3. Remember, the ones having negative, they have to be on the denominator. The ones having positive, they have to be on numerator. But if both are having positive, the ones having positive, multiply them. So in this case, I only have one having positive. The bases are the same, remember. So I'm going to say I've got z plus 1 raised to the power half. The rest are having negative, so they have to be on the denominator. So I'm going to say x to the power 2 times y to the power 4 times z to the power 3, meaning now this is my answer. Okay, now if you check question 8, we are coming now from here to go back to this. So that's why I want us to do first question 9, so that we have an idea of what is happening on question 8. Okay, there we go. So we're going to have part C, which is 2 log base 3 of this plus 6 log base 3 of x minus initially this is supposed to be in the brackets. This was just an error. X minus 1 over 3. These are supposed to be in brackets. They can't be in. So there we go. Let's see. You have to shift what is in front here to be the power. So I'm going to have log base 3 of x plus y has to the power 2 plus log base 3 x minus 1 over 2. This has to be the power 6. Let's now see. It is plus, so we have to divide, or we have to do times, since there is plus. Log base 3 x plus y to the power 2 times x minus 1 over 2 to the power 6. In this case, this is my answer. Okay, that is it for question 9. Now let's go to question 8. we are running away from condensed. We want to expand it. The first one is log base 7. I have got remember I've got 10 a7 b3 c to the power negative 8. So I've got how many things here? Let's see. I have got a number. I've got 1 2 3 4. Okay, meaning that I've got log base 7 of 10 plus, since there's times here, so again another one is log base a. Everything is going to be in base 7. Okay, base 7 of a to the power 7 plus log base 7 b to the power 3 plus log base 7 of c raised to the power negative 8. Now at this point I can say log base 7 of 10 plus, I can now shift 7 to be in front. I can say 7 log base 7 of a plus, I can shift now 3 log base 7 of b plus, I can shift that negative 8 and put negative here, negative 8 log base 7 of c, meaning this now it is the one which is not in condensed one. We are running away from the condensed one to expand it. We have just expanded here. So if I want, I can also go back to this and I'll reach there. Okay, so that is it for part A. Let's see how we can solve part B. So part B, we have log z to the power this, then x squared plus 4 to the power 3. Okay, now even here we can see that there is times, meaning it is plus. So it is in base 10. They are not showing any base here, meaning it is in base 10. So we have got log. The first one is z to the power 2 plus log, but remember again, here is supposed to be like this. Here is going to be log now x to the power 2 plus 4 raised to the power 3. Now I can shift the power to be in front, so it's going to be 2 log z plus, here I'm going to shift 3 log x squared plus 4. In that case, this is my answer. If I want, I can also run away from here all the way to there, meaning now I'm condensing it. Let's do the last one, which is part C. So part C is ln, we have got w squared, then the fourth root of t to the power 3 divided by the square root of t plus w. Okay, that is what we have. Now let's see what we're going to have. Remember the one having division, but I can first simplify this and say, or I can do this. This is the same as ln w to the power 2. This one, if I have got the fourth root of t, is the same as t to the power 1 over 4. Now this is the fourth root of t to the power 3, meaning it is the same as 3. We have got t 3 to the power 4. That's the meaning. So like in this case, I'm going to have t raised to the power 3 over 4 divided by t plus w. Since that is just the square root, it's going to be to the power half. Now I can see clearly to say this is going to give me ln w to the power 2 plus, because this is these two are multiplying, again ln t to the power 3 over 4. Then again, now the down part is going to be minus ln t plus w 1 over 2, because there is division here, so it's going to carry a negative. Now from here, what else can we do? We can see that let's get rid of this. We finish. The powers are supposed to be in front. So in that case, I'm going to say I have 2 ln w plus 3 over 4 ln t minus ln. Now I'm going to drop negative half, or I'm going to drop half. Then I'll have ln t plus w. So in that case, this is going to be my answer. Again, if I want, I can run away from here to there. So that is it for for question 8. Now let's go to question 10. Now question 10 is talking about sketching the logs. Now, like I said, log and ln, they are the same. So when you see ln and log, we're talking about logarithmic. When you see e, we're talking about exponential. So in this case, before we start from point 1, let's have a simple log. It's the same, guys. If I have got log, let's say log x, we don't have any base, just know that we have base 10. Now to graph this logarithmic function, they have got what we call the vertical asymptote. Okay, so the vertical asymptote, you have to equate this into 3 things. You equate x has to be equal to the base. Okay, so I'm going to equate that into 3 things. I'm going to equate x to be equal to 0, then x to be equal to 1, and x to be equal to the base. So in that case, the base is 10. Now the one which you equate equal to 0, that is your vertical asymptote. So in this case, the vertical asymptote is 0. Then these two are the ones we're going to use to plot. Okay, so in that case, I'm going to say my vertical asymptote is 0. Next, I need to have this. So I'm going to say when x is 1 and when x is 10. So I'll start. When x is 1, any log, regardless of any base, as long as it's log 1, regardless of any base, is 0. So in that case, we're going to have log base 10 of 1. Any base of 1 is 0, regardless of any base. Okay, so in that case, it's going to be 0. Now what of 10? Meaning we've got log base 10 of 10. Remember we said if we've got the base of itself, that is going to give us 1. So definitely that is going to be 1. Now how can we graph this? Remember we said log has got what we call vertical asymptote. So here is going to be my graph. My vertical asymptote is 0. This is the line for 0. Now this is the horizontal asymptote. What I'm doing, this is wrong. We are saying it is the vertical asymptote. Vertical has to be vertically here. So this is going to be my vertical asymptote. So in x we have got 1 and 10. So I'll put 1 and 10. In y I've got 1 and 0. Okay, so the first point here is 1, 0. 1, 0 in x is 1, y is 0, is this line. Next is 10, 1 is this point. Now running away from the asymptote, going there. That's the meaning. So I have to put an arrow there. Now we can also clearly see that the domain here is restricted. The domain in this case is from 0 all the way to positive infinity. We don't know where it is ending, So now here, we know where it is starting from. It's starting from 0, but 0 is not included because it is running away from 0, going all the way to positive infinity. But the range, this is the opposite of what we were talking about in question 3, where we are talking about sketching exponentials. So the range in this case is always from negative infinity all the way to positive infinity. Now the domain for the exponential function is from negative infinity to positive infinity, but the range is restricted. Now when it comes for log, the domain is restricted, but the range is from negative infinity all the way to positive infinity. Okay, so in this case, this is our graph. Now let's go back now to our question. That is just example which I was trying to give you. Our question now here is, we have ln now. So now just before we go to ln, let me give you another example where we have, anyway, let's just go back here. I'm going to explain. So what we're going to be doing here is the same even if they give you len, even if they give you log. So I've got negative x. Remember, this is log. You equate this into three things. One, I'm going to say negative x has to be equal to 0. The one I'm equating equal to 0, that is my vertical asymptote. Next, I'm going to equate this equal to 1 and equal to the base. We said len is always in base e. That's what we said. So the base is e in this case. Len has got always base e. So the first I'm going to say my vertical asymptote is 0 because this is my vertical asymptote. Next, I have to get that other one. So x will be equal to, I'm solving this. I'm going to divide both sides by negative, negative, I'm going to get negative 1. Next, I'm going to have x. If I divide this to negative, it's going to be negative e. Okay, now I no longer need this. So just equate that. What you have there inside, equate it equal to three things. One, equate it equal to 0. The one you're equating equal to 0, that is your vertical asymptote. Next, equate it equal to 1. Those are the coordinates now. And equate it equal to the base. Then, come up with a simple xy coordinate. xy. So now, I've got my function here. Where there is e, okay? Where there is x, let's put negative 1. So this is going to be e. I'm going to have negative 1. I'm going to say 1. Now we said, regardless of any base, as long as you have got 1, definitely it is 0. Okay? Definitely is going to give us 0. That's what we said. So I'm going to say if this is negative 1, I'm going to get 0. Next, if this is negative e, what will be our? This is going to be len negative e, which is going to be len negative will cancel. So here there is the e. So that one is going to give us 1. Now we can have the graph of this. Let's see the graph which we are going to have. So here is going to be my graph. So I have got in x, I have got negative 1 and negative e. Remember e we said is approximately 2.178, somewhere there. So in y I have got 0 and 1. What is our vertical asymptote? Our vertical asymptote is 0. So this is the line. It has to be running away from this line. Now we can plot this. We can see that we're going to have negative 1 comma 0 is this point. E comma 1 is this point. So running away from the asymptote going there. That is going to be our graph. From here we can see that the domain is from negative infinity all the way to 0. But the range is always from negative infinity to positive infinity. Okay, that is it for part A. Let's go to part B. What is part B saying? So part B is saying we have g of x to be equal to ren x minus 3. You equate what is inside here, only what is inside here, to three things. I'm going to say x minus 3 has to be equal to 0, x minus 3 is equal to 1, and x minus 3 is equal to the base. The base in that case is e. Now, the one which you are equating equal to 0, that is your vertical asymptote. So x is going to be equal to 3, that is going to be my vertical asymptote to be equal to 3. I'm done with this part. These are now going to be my coordinate. X minus 3 is equal to 1, x is equal to 1 plus 3, x is equal to 4. That is my first coordinate. I get rid of this. Next, I'm going to have x minus 3 is equal to e. So x will be equal to e plus 3. That is my next coordinate. E plus 3. We are not using a calculator, so just put e. That is just okay. And we know that e is 2.17, meaning that 2 plus 2.17 plus 3 is going to be about 5 point something. That is just okay. Let's have this now. If x is 4 and if x is a plus 3, what will be the value of y? Let's see. Ln, if x is 4, I have 4 minus 3, I have ln 1. Remember we said this is base a. Regardless of any base, as long as we have 1, that is going to give us a 0. Okay, so I'm going to have 0 here. Now what if ln is e plus 3? What will be our answer? Let's see. If x is e plus 3, I have got minus 3 here, so I have ln e, this and this will cancel. Remember it's base e. This is going to give us 1. Next, I can plot this now. I'll have my graph. In x I have got 4. Okay, I'll put 4 here. Let's first we have the vertical asymptote. Let's not forget the vertical asymptote is 3. Then we have got 4. We also have e plus 3. So I'll put first my vertical asymptote here. It has to be running away from that line. So we have got 4, 0 is this point. Next, e plus c, I have got my 1 here. E plus 3, 1 is this point. So running away from 3 all the way going there. That is going to be our graph. We can see from here that the range is from 3 all the way to positive infinity. Sorry, the domain, because domain is the x values, but the range is from negative infinity all the way to positive infinity. So that is it for part B. Let's see how we can do part C. So part C, we have h of x to be equal to, we have ln x plus 7. Remember, we are only getting what is part of the ln. This is just x. I equate it equal to 3 things. Okay, we equate it equal to 3 things. What are those 3 things? We are going to say we have x is going to be equal to 0, x is going to be equal to 1, x is going to be equal to the base, which is e. The one we are saying equal to 0 is our vertical asymptote. Our vertical asymptote in that case is 0. As simple as that. Next, we are going to say our coordinate, we're going to have x is equal to 1 and x is equal to e. Let's see. X, y. If my x, I can now get rid of this. If my x is 1 and if my x is e, what will be the value of y? Let's try. If my x is ln 1, regardless of any base, as long as we have 1, log and ln is going to be 0. So it's going to be 0 plus 7. 0 plus 7 is 7. We are done with that. Next, I'm going to put e. Let's see. So I have got ln e plus 7. So this is base e. Ln e base e is 1. 1 plus 7 is 8. Okay, I'm done with that. We can now have our graph. So here's going to be my graph. Okay, in x-axis I have 7 and 8. I'll put 7 and 8. If you want, you can put 1, 2, 3, 4 all the way up to 7. But here then I have got 1 and e. This is e, this is 1. Let's start. Our vertical asymptote is at 0. So I'll have my vertical asymptote here. Horizontal is in this line, vertical is there. Okay. So now we are saying 1, 7 is this point. E, 8 is this point. Running away from the asymptote, going there. That is our graph. A very nice graph. Okay, now from there now, we can see that we are going to have, that is our graph, so we can go to part D. So part D is f of x to be equal to ln x plus 2 minus 4. Now from here we can clearly see that we equate this equal to 3 things. We're going to have x plus c equal to 0, x plus 2 equal to 1, x plus 2 equal to the base. The base is a. Okay, so if the base is a, remember the one which we are getting equal to 0, that is our vertical asymptote. Let's solve for x. X plus 2 is equal to 0, so x is going to be equal to negative 2. So our vertical asymptote in this case is negative 2. Okay, we are done with that. That is just the coordinate which we are going to use. So now the next thing which I have to do, I have to find the x values. Okay, so I'm going to say x plus 2 is equal to 1. Let's solve for x. X is going to be equal to 1 minus 2, so x will be equal to negative 1. That is going to be my first coordinate. X is equal to negative 1. Now let's go to the second one. So the second one is x plus 2 is equal to a. Let's shift this to the other side. So x will be equal to e minus 2. So x will be equal to e minus 2 is my second coordinate. Okay, so now if x minus e minus 2 is my second coordinate, let's have now we find the value of x, or the y now. So we have got x, y. Okay, so if x is negative 1 and x is e minus 2, what will be the value of y? Let's see. So we're going to have ln x is negative 1 plus 2 minus 4. So it's going to be ln, I have got negative 1 plus 2. Negative 1 plus 2 is 1. So I'm going to have 1 here. Okay, I'm going to have 1, then it's going to be, I have 1 minus 4. So ln 1 is going to give us 0. So I've got 0 minus 4, which is going to give me negative 4. Next, I'm going to put e minus 2. Okay, so let's see. If I put e where there's x, I'll put e minus 2 plus 2, then minus 4. So I'll have ln, then I have negative 2 plus 2 is going to give me 0. So definitely I'll remain with e minus 4. So I'll have ln e of e, which is going to give me 1. Okay, minus 4. So I'll have 1 minus 4, which is going to give me negative 3. So I'll put negative 3 here. Now, next what I have to do is I can now have my graph. So here's how my graph is going to be. So I'm going to have my nice graph here. I have my y, I have my x-axis. So my vertical asymptote, remember, is negative 2. So let me just put this line to be on top a bit. Okay, so my x value, I have negative 1, which I'm going to put here. But this is e minus 2. E is basically 2.173, somewhere there. So which I'm going to put is a positive number. I'm going to put it here, e minus 2. In y-axis, I've got I have negative 2 as a vertical asymptote. I have got negative 3. I also have negative 4. Okay, now from there, now I can see that negative 1 comma 4, where is it? I have got first we can have our vertical asymptote, which is here. That is our vertical asymptote. So I've got negative 1 all the way to comma 4, which is this point here. Okay, next I have e to the power which is going to be which point? Let's see. We have e to the power negative 3, which is this point here. Okay, now okay, so we are saying the vertical asymptote is supposed to be, this is what I've done here. I've written horizontal asymptote, okay, instead of vertical asymptote. So this is supposed to be like this, supposed to be the vertical asymptote and not horizontal, and don't make that mistake. Okay, so I have to put my negative 2 here. I'm going to put my negative 2 here. Where there's negative 2, that is my horizontal vertical asymptote. So it has to be running away from this line. Now the first coordinate is negative 1 comma 4. Okay, negative 1 comma 4, that is my first coordinate. So I'm going to put it there. uh, -1 is here, comma, -4 is this point. Okay, perfect. Now e to the power that one, then we have got to the e to minus 2 to the power comma -3, which is this point. So basically it's supposed to be running away from this line, then it's supposed to be coming like that. But I can put a nice, like a nice graph, like in this case. I'm going to say, let's put it here, a nice graph where we're going to have this. So here's going to be my nice graph. Okay, I'll put it like this because everything is down, so I'm going to put it like this. So I have my vertical asymptote at -2, and also I have got what, -1 here. Then I've got e minus 2, which is to the positive side. Then the y-axis I've got -3 and -4. So my vertical asymptote, like we have said, is that it is at -2, which is this line. Or let me just put -4 just a bit on top here. We see what's going to happen. We want our graph to come out perfect. So here's going to be my -3, here's going to be my -4. Okay, now it's making sense. So I've got -1, -1 comma -4, which is this point. Then e comma 3 is this point here. So running away from the asymptote, going like that, that is going to be our graph. Okay, I even put my arrow there, so I can see that the domain of this function is from -2 all the way to positive infinity. The range is always from negative infinity to positive infinity. So that is it for part D. Let's go to part E. We see how we can solve part E. Now part E is saying g of x is equal to ln x minus 6 plus 2. Remember, you have to equate this into three things. I'll do x minus 6 is equal to 0, x minus 6 is equal to 1, and x minus 6 is equal to the base, which is a. Now, the one which I've equated equal to 0, that is my vertical asymptote. Okay, so I have to solve for x. So it is x minus 6 is equal to 0. X, if I shift x to the other side, it's going to be equal to 6. That is my vertical asymptote. So my vertical asymptote in this case is 6. I'm done with that. So now from here, I'm going to solve the values now. The second one, I've got x minus 6 is equal to 1. I'll shift -6 to the other side. I'm going to say x is equal to 1 plus 6. So my x will be equal to 7. That is going to be my first coordinate. Okay, let's go to the second one. We see what's going to happen. So I have x minus 6 is equal to e. So it's going to be x is equal to e plus 6. That is going to be my second coordinate, e plus 6. We are done. Now let's find the values of y. Then we have our graph. Okay, so I have this, I have x, y. Let's see. If x is 7, what would be the value of y? Okay, so we have got ln if x is 7 minus 6 plus 2. So I have 7 minus 6 is 1. Okay, plus 2. So we have got ln 1, regardless of any base, this is definitely 0. Plus 2, that is going to give us a. So if x is 7, the y value has to be 2. It's going to be 0 plus 2. Next, I have to put e plus 6. Let's say we put e plus 6 ln, so I have got e plus 6, again minus 6, plus 2. So 6 minus 6 is going to give us 0. We are meaning with e only. So ln e, remember, is in base e plus 2. Ln e of e is 1. So I'm going to have 1 plus 2, which is going to give me what? It's going to give me 3. So if x is e plus 6, then we expect our y to be 3 because it's 1 plus 2, 3. Now that we have our graph, our coordinate, let's have our graph. Remember, the vertical asymptote in that case is 6. Okay, so I'll have this. Okay, so my vertical asymptote is at 6. Let me put my 6 here. Okay, let's just do this. Let me put it here to say this is my 6. Next I'm going to say this is my 7. Then next I'm going to say this is my e plus 6. Now this graph is not supposed to touch this line. That is our vertical asymptote. What else do we know? We can also see that we have got in y-axis we have got 2 and 3. I'm going to put 2 here and then here 3. Let's see. So I have got 7 comma 2 is this point. I have got e plus 6 comma 3, which is at this point. Learning away from the asymptote, going there, that is going to be our graph. Now from here we can see that the domain of this function is from 6 not included all the way to positive infinity. The range is always from negative infinity all the way to positive infinity. So this is what we need to know under sketching of what? Logarithmic function. So that is it for question 10.